Good day, everyone. Our project title is Investigation of Magnetic Field Distribution and Gauss's Law for Magnetism using physics. The objective is to study magnetic field strength, magnetic field direction, and to demonstrate Gauss's law for magnetism. A permanent magnet produces a static magnetic field. Magnetic field has both magnitude and direction. Gauss's law for magnetism states that the net magnetic flux through any closed surface is zero. This means magnetic field lines form closed loops and isolated magnetic poles are not observed. When we use the fifth box to measure the magnetic field, before the experiment, the background magnetic field was measured without the magnet. This background value includes the Earth's magnetic field and the surrounding environmental magnetic field. During the analysis, the magnetic field change caused by the magnet was estimated by subtracting the background value from the measured value. In the first experiment, the smartphone is fixed in one position and the magnet is placed at different distances. The absolute magnetic field value is recorded using physics. The result shows that the magnetic field strength decreases as the distance from the magnet increases. We take 3 measurements at a given location and then use the average value as the final magnetic field strength. In the second experiment, we investigate the direction of the magnetic field near the north pole and south pole of the magnet. First, the smartphone is kept in a fixed position and its orientation is not changed throughout the measurement. The distance between the magnet and the smartphone is also kept constant to make sure that only the magnetic pole is changed. Then, the north pole of the magnet is placed near the phone and the magnetic field reading is recorded using physics. After that, the magnet is turned around and the south pole is placed at the same position and same distance from the phone. The readings obtained from the north pole and the south pole are different. In some cases, the value on y-axis may even change direction or sign. This shows that magnetic field is a vector quantity, which means it has both magnitude and direction. In the third experiment, we use a compass to observe the magnetic field direction around the magnet. The compass is placed at different positions, such as near the north pole, south pole, above and below the magnet. At each position, the compass needle rotates and aligns with the local magnetic field. By recording these directions, we can sketch the magnetic field lines. The observation shows that the magnetic field outside the magnet goes from the north pole to the south pole. These field lines form a continuous loop which supports Gauss's law for magnetism. The results show 3 main findings. First, the magnetic field strength decreases as the distance increases. Second, the north pole and south pole give different magnetometer readings, showing that magnetic field has direction. Third, the compass observation shows a continuous magnetic field pattern around the magnet. These observations support Gauss's law for magnetism. One limitation is that smartphone magnetometer can be affected by Earth's magnetic field, nearby metal objects, and sensor noise. To reduce error, the phone rotation was kept fixed, and each measurement was repeated 3 times. For safety, the magnet was not placed directly on the phone. In conclusion, this experiment successfully demonstrates magnetic field distribution and supports Gauss's law for magnetism.